Now that we're familiar with simplifying radicals, we're going to be discussing operations with radicals. Math operations will be covered in this, and the next video will be multiplication. Multiplication will be covered in this video. And division and additions and or subtraction, which is really just addition of negative values, will be covered in the next video. Let's move along. So when simplifying radicals, we kind of covered some of this in the last video. When simplifying radical expressions, there's three rules, right? Three rules. One, you cannot leave a perfect square underneath the radical. So we had in that last video the product property, right? Where you take A and B, right? You take a number, say like 27, and you pull it apart into 9 times 3, right? But underneath radicals, right? So you have radical A and radical B. I can pull that out of separate them into two separate products, and thus square root of 9 is 3, rad 3. So the square root of 27 is 3 rad 3. The other two radicals, or the other two rules are that you cannot leave a fraction, right? Cannot leave a fraction underneath the radical, and you cannot leave a radical in the denominator. So we've covered this. We're just sort of double checking our skill set. First one, all right, or I should say that rule number 2, we covered rule number 1 in the simplifying radicals video. Second rule, right, you can't leave a fraction underneath the radical. So what do? You separate it, right? So if you have one big radical, separate it into two radicals. Just like the product property, we now have the quotient property. So you're going to have the square root of 1 over the square root of 4. Okay, the square root of 4 is 2. The square root of 1 is 1. So the square root of 1/4 is 1/2. Okay, that's the first one. I have my B's and C's backwards, so I'll go over to B first. So this would be the square root of x to the 100th over the square root of 49. Square root of 49 is 7. Square root of x to the 100th is a perfect square. Divide that by 2, you get x to the 50th. Okay? And then lastly, over here, you have the square root of 25 is in the denominator, and on the top, the square root of 3m to the 11th. Now on the bottom, we have ourselves a nice perfect square, but on the top, we're going to have to break that apart into several radicals, right? We're going to have the square root of 3, the square root of m to the 10th, and the square root of m. M to the 10th and the m, right? These two give me m to the 11th. I pulled that apart, and now we're going to be able to reduce the perfect square, which is m to the 10th. So that's going to be m to the 5th. What stays under? 3m all over 5. So now we don't have a radical in the denominator, and we didn't leave the radical under a fraction. So we are in good shape. If any of that was too fast, just rewind, go back and watch that again. And then lastly, you cannot leave a radical in the denominator, right? So you're going to have to rationalize the denominator, right? And rationalizing would involve, right, multiplying the numerator and the denominator by that radical that's in the denominator. And what that will do is it will release the bottom value, right? So first things first here, I see rad 2 over rad 5, so I'm just going to rewrite it as rad 2 over rad 5. So, okay, well, the problem is 5 isn't a perfect square, so I'm going to multiply by the radical in the denominator, right? And so the square root of 5 is an irrational number, and what we're going to do is we're going to land with a rad 10 on the top, rad 25 on the bottom, which reduces to 5, or simplifies to 5, I should say. And now 5 is a rational number, hence the term rationalizing the denominator. So we're left with rad 10 over over 5. Do not, whatever you do, reduce that to the square root of 2, right? The 5 is, right, whole number. It's not under a radical. Radicals can play with radicals, but that's it. Okay, so now at the bottom, we got rad 1 over rad 2, step 1. Step 2, multiply by the radical in the denominator. Step 3, figure out what happened. Last step, simplify. Now, if you can go from here all the way to here in one step, that magical piece is going to happen every time. Okay, so we got rad 10 over 5, rad 2 over 2. Next one, we have a negative. No problem. Let me just clean up the space a little bit. All right, so we got a negative rad 5 over rad 7. Where's that negative go? Wherever, out in the front. The whole value of this thing is negative. It's not attached to the 7. It's not attached to the 5. Just the value of rad 5 divided by rad 7 is negative. Okay. So now I'm going to multiply by rad 7 on top and bottom. And I'm going to get negative rad 35 over 7. And that's about it. So we're going to move on. We have plus and minus rad 8 over rad 3. First things first, separate them. Then multiply top and bottom, or the numerator and denominator, by the radical in the denominator. It's going to give us plus and minus. Now, rad 8, I'm just going to kind of leave this like this for a second. And that's a plus and minus over 3. Now up on the top, we have a plus and minus 4, 2, and 3, all over 3. So that 4 becomes a plus and minus 2/3 rad 6 on the top. Now again, if you want to just cross that out and make that a 4 times 2, and then bring the 2 out right there, and then make that a 6 right there, and you can handle all that in one fell swoop, go for it. Right? How many steps you write out is up to you. So really all that prior stuff was all about simplifying, right? We were simplifying. Now we want to talk about multiplying radical expressions. Piece of cake. Rad 7 times rad 3 is rad 7 times 3, which is rad 21. Now, if anybody can be broken down in the meantime, I would encourage you to break it down first. So in this next example, I have 3 times rad 3x to the 7th times 6 times rad 2x to the 3rd. So my first thing is I'm going to combine 3 times 6, right? That would give us 18. And then we have the two radicals that multiply nicely. So I'm going to say 3 times 2 is 6. X to the 7th times x to the 3rd is x to the 10th. I'm going to add my exponents when I multiply variables, okay? Now x to the 10th is a perfect square, so that's going to simplify to 18 x to the 5th. I'm going to divide by 2, and I'm going to leave the 6 underneath because 3 times 2, neither one of those are perfect squares. So my final answer is bada boom, right there. All right, C. Okay, I got my 2 and my 5. That's going to give us a 10. And then that's going to be 4 times 6 is 24. And x to the 11th times x to the 4th is x to the 15th. Maybe I got a little overzealous on my radical. Okay. And now I know that that's going to be 10. 24 is going to be 4 times 6. X to the 15th is going to be x to the 14th times x, which gives us a final answer of, this becomes a 2. So that's going to be 20 because 10 times 2. 6 stays under. The x to the 14th becomes x to the 7th. And the other x stays under. So I've covered just about everybody. I'm just going to rewrite that as 20x to the 7th, rad 6x. I don't want that 7 confused as the index on the radical. Okay, now for distribution, no big deal. We're taking that 3 rad 3, we're going to multiply it by 2, and we're taking the 3 rad 3, and we're going to multiply it times negative 5 rad 2. So just on the previous slide, just we're doing a little bit extra. All right, so 3 rad 3 times 2 minus 3 rad 3 times 5 rad 2. Okay, well the 3 rad 3 times 2 is going to be 6 rad 3 minus the 3 times the 5 is 15 rad 6. And we're all set. That's it. Just 6 rad 3 minus 15 rad 6. Not a big deal. Okay, now we have a binomial times a binomial. So you know this is FOIL, or you could just sort of look at it as the 1 times the 4 and the 1 times the negative 5 rad 6. And the rad 3 times the 4 and the rad 3 times the negative 5 rad 6. FOIL is just a very particular way of saying distributing 2 different values to 2 different values, or binomial times a binomial. So let's see, 1 times the 4, and then we're going to do minus 1 times the 5 rad 6. We're going to add that to rad 3 times the 4 and minus rad 3 times the 5 rad 6. All right, so I have my 1, 2, 3, 4 terms. We'll see if anybody can go together at the end. 1 times 4 is 4. Negative 1 times 5 rad 6 is minus 5 rad 6. Rad 3 times 4 is just plus 4 rad 3. And rad 3 times rad 5, or 5 rad 6 is going to be minus 5 rad 18. Okay, so now what do I notice? I notice that the rad 18 can be broken down into 5 rad 9 rad 2, which is a 3. Okay, so that's going to be, let's just sort of put a break here. That's going to be 4 minus 5 rad 6 plus 4 rad 3. And then this became 5 times 3 is minus 15 rad 2. So 4 minus 5 rad 6 plus 4 rad 3 minus 15 rad 2. And since none of the radicals are the same, nobody goes together, we're going to leave that as our final answer. Let me clean this up a little bit and make room for letter C. Again, this is just a binomial times a binomial. So we're going to distribute our rad 7 times rad 7. And then our rad 7 times a positive 1. And then minus 1 times rad 7. And a minus 1 times 1. Okay. This gives us rad 49, which is just 7. Plus 1 times rad 7 is just rad 7. Minus 1 rad 7 minus 1. And although we haven't formally covered it, my guess is that a positive rad 7 and a negative rad 7 cancel each other out, and 7 minus 1 is 6. Finito. That's all you got for now. So just move on to your next assignment that I will post, and take your newfound simplifying skills and multiplying skills and have at it. Reach out for help if you need any.